So now we're going to take a look at this and apply this information to understanding the energy density. Now we know from chapters 25 and 32 that the electric energy density is 1/2 epsilon naught times the electric field squared, and we know that the magnetic energy density is 1/2 over mu naught times the magnetic field squared. But we also know that the magnetic field is just the electric field over the speed of light. Now you may be saying, wait. Isn't it the electric field over the speed of light only for the maximum? Well, yes and no, because they both follow the same sine function. So it really works for both. It's the electric field over the speed of light. That means that the magnetic energy density is 1/2 mu naught E squared over C squared. But mu naught C squared, we know that mu naught epsilon naught is equal to 1/c squared. Switching the c squared with the epsilon naught, I get that mu naught epsilon naught, mu naught c squared, is equal to 1/epsilon naught. Plugging that in here, this is just 1/2 epsilon naught E squared. In other words, the magnetic energy density and the electric energy density are exactly the same. UE is equal to, UE is equal to UB. So what we see is that the energy density of the electric field is equal to the energy density of the magnetic field at every instant and for every point along an electromagnetic wave. That's true for a simple sinusoidal traveling wave. It's not necessarily true for other kinds. For example, for electromagnetic standing waves, it doesn't hold true. In general, the total energy density is the electric plus the magnetic, 1/2 epsilon naught E squared plus 1/2 mu naught B squared, or I could just as easily write it as epsilon naught E squared, or as B squared over mu naught. Any of those forms is equally valid.